So parallel lines that have the exact same slope. That's what they have in common. Let's say that you have an equation like y equals 2x plus 3. First off, what form is that in?
Y equals M.
Absolutely, y equals mx plus b, slope-intercept form. Now, this is probably, now we talked about standard form and point slope form. This is probably the easiest one to look at, first off, because the slope is clearly written and the y-intercept is clearly written. Okay, this is probably the easiest one to work with. Okay, so that's slope-intercept form. So we always try to get it in that form because I think that's the easiest one to work with. So according to our parallel lines, if they have the same slope, let me write another equation down. Would those two be considered, so those are two lines essentially, right? Would those two be considered parallel? Why not?
They don't have the same slope.
So you think not?
Oh, wait, no, they do have the same slope. Sorry. Yes.
Yes, they are considered parallel lines. This would be a yes, because look at their slopes, okay? We have essentially a slope of 2 here and essentially a slope of 2 here. So yes, these would be considered parallel lines. That's literally all you're doing, is just seeing if they have the exact same slope.
So the line behind the slope can be different.
Yes, perfectly right. Notice that the thing behind the slope can be different. First off, what is that thing?
The y-intercept.
Yes, the y-intercepts can be completely different. I mean, let's say if this was plus 3 like it is, this could be negative 4,858. Okay, it doesn't matter. It's going to be real spaced apart, but the slopes, if the slopes are the exact same, then they are considered parallel. Okay, so when you're looking for a parallel line, just look at the slopes. Let's say if we had a y equals 2x, let's not go with 2x, we already mastered that. Negative x minus 1, and y equals negative 1x plus 4. Would those be considered parallel lines?
Yes. Yes. They have the same slope.
Yeah, the one's just not there. Don't need
Absolutely. Amanda said it right. Freddie was right. I think Anna, somebody else said that was right. Yes, those are considered parallel lines. Now, the first one just has a negative x. The second one has a negative 1x. Those really just mean the same thing. Okay? You could put a 1 in front of that and make that look a little bit better, and then you can just write yes underneath it. Okay? Let's go over one more example. So y equals negative 2 over 5x plus 4, and y equals minus 2. Let's say if we had this last one, would those be considered parallel? Would these two slopes, these two lines, remember this is an equation of a line, would these two lines be considered parallel? No, because they do not have the same slope. Pretty simple. Does everybody have this one down? There's slopes. Now, there's two ways where I like to talk about it. The technical term is their slopes are they're reciprocal. I don't know if I spelled that right, but it's okay. You can think of it as the complete opposite. So if you want to think about it that way, you can think about it as the complete opposite. So if you want to write that down, you can. It's really just the complete opposite.
So like if you have like your slope is 2/3 x, it'd be 3.
Close. Very close. So let's just look at the slope. So let's just say we had a slope of 2. Okay? A slope of 2. So m is equal to 2, so that means the slope is equal to 2. Okay? A reciprocal or a perpendicular slope would be m would be equal to, first off, if it's positive, you make it negative. So Dakota, you're on the right track. He's thinking, okay, if it's positive, okay, I know it has to be a negative. That's right. Now, Freddie had the other part right. I like to think about it as it just flipping it. So if a slope, so 2 would be considered really 2 over 1 in terms of slope. So if you just needed to flip it, just flip it, 1 over 2. So these would be considered perpendicular slopes. Let's go over another example. Let's say if we had an m is equal to a -4. What's a perpendicular slope to that? What you got? Positive? Not 4 over 1. 1/4. Because remember, this is a whole number, just put it over 1. So if it's negative, make it positive. I think Damien had that part right. If it's negative, make it positive. And if it's 4 over 1, really, 1 over 4. Okay? So these would be considered perpendicular slopes. This can be very... Does everybody see that? So for y, I inserted a -3 right here. For my slope, what am I going to insert? 2. For my x, what am I going to insert? -2. And we're going to solve for b. Does everybody see how I set that up? Does everybody see that? So I used that point, that x and y point, and I used the slope, which I know is going to be the exact same because we're talking about parallel lines, and I just plugged it into my slope-intercept form. And now, hello. And now we're going to solve for b. So this is going to give me a -4 here. So I'm just working this out. Then you would add 4 to both sides. You would have a +1 is equal to b. Okay? So far, so good. Put that up, please. It is not lunchtime, buddy. Where's your workbook at? Okay. What I have to do is, let's say we need to put this in slope-intercept form. So your answer, which I'm going to write in, let's go green, is going to be y equals, you can't really see that, can you? Forget the green one. Let's go blue. Absolutely. Y equals 2x plus 1. It's that simple. So use the x and y, use the slope, and then you need to just find your y-intercept and go from there. Any questions on that?